Hello guys, welcome back. Today's topic is IPv4 versus IPv6, or we can also say that IPv4 and IPv6 coexistence. What we mean by this topic is, what I mean to say is that right now or nowadays we have both IPv4 and IPv6 present in our environment, right? Some devices are operating on IPv4, some devices are operating on IPv6, and some devices are operating on both, right? The structure of both are different, the address space of both are different. One is 32-bit, one is 128-bit, and the way the addresses look like, they are also different, but still these devices are able to communicate with each other. What I mean to say is that a device that is operating on IPv4 is also able to communicate with a device that is operating on IPv6. Now, how is it able to do so? Even though IPv4 and IPv6 header size is completely different, right? They are completely different, but still they are able to communicate. Okay, how is it so? Okay, first of all, there is no specific date. Okay, there is no specific date that has been given since the origin of IPv6, that when or exactly at what date we are going to move to IPv6, because it is a costly process, it is an expensive process, right? Both IPv4 and IPv6 are going to coexist in the future as well. Okay, and this transition that is happening from IPv4 to IPv6, it is going to take a lot of time. Obviously, it is going to start from the bigger organizations, but it will soon jump on to smaller ones and to the individual persons as or retailers as well. Okay, now the when we talk about what we can say that when we talk about the migration, okay, migration towards IPv6, how it is done, how a device that is operating on IPv6 is able to communicate with a device on IPv6, or a device that is operating on IPv6 is able to communicate with a device that is operating on IPv4. Okay, just understand this thing, how these devices are able to communicate with each other even though they are on different type of internet protocol versions. Okay, so there are different techniques for it. Okay, there are different techniques, or mainly there are 3 techniques for it. Okay, 3 techniques for it. The very first technique that is there is known as dual stack. This is the very first technique. Okay, what it does is, what it means is, you guys can refer to my notes, or you guys can refer to my diagram that would be shared in the Telegram group. Okay, just pay attention to that and you will be getting the notes of it. Okay, what happens in dual stack is, okay, basically a dual stack allows IPv4 and v6 to coexist on the same network segment or network environment. This is the first thing that I have. Alright, then dual stack devices, okay, the devices that are having this technique facilitated in them, those devices can run both IPv4 and IPv6 protocol stacks simultaneously. Okay, so they will be able to run IPv4 protocols as well as IPv6 protocols simultaneously. So there won't be a problem with respect to that as well. Okay, alright, got it. Now this is what happens in dual stack. Okay, it basically, this technology allows to IPv4 and IPv6 to exist in the same network segment only, and all the devices which are operating on dual stack, they handle both the protocol stacks simultaneously in a seamless manner. Then the second technique that is there is known as tunneling. Okay, now what is tunneling? right? Basically tunneling is what I can say that tunneling is, let's say there is a device, there is a source device that is operating on IPv6. Okay, so IPv6 is there. So obviously if the device is operating on IPv6, it is going to send what? It is going to send an IPv6 packet only, right? It is going to send IPv6 packet. Now tunneling does what? Tunneling allows an IPv6 packet. Okay, tunneling allows your IPv6 packet to travel over an IPv4 network as well. Okay, even though your packet is IPv4, but it allows this packet to travel over the IPv4 network. Okay, how it happens? Whatever your IPv6 packet is, okay, it will be encapsulated inside an IPv4 packet, and from outside environment, it looks like it is an IPv4 packet only. Okay, at the receiver the data packet would be decapsulated and the IPv6 packet would be identified. Alright, done? Is there any doubt? Cool. Alright, the next one that we have is the third one, that is known as translation. Okay, now what is translation? Alright, this translation is related to NAT. Okay, basically NAT 64 is used over here, which stands for network address translation version 64. Okay, it allows your IPv6 devices, okay, it allows IPv6 devices to communicate with what? IPv4 devices using translation technique, which is similar to network address translation in IPv4. I hope you remember that class. Okay, we had talked about network address translation in IPv4 when we were required to access a public IP address using an private IP address, and we already know private IP addresses are not internet routable, so we are supposed to access internet only. Okay, so that is done with the help of NAT. Okay, so this is how NAT 64 also works. Okay, so what happens within NAT is an IPv6 packet is translated to an IPv4 packet, and an IPv4 packet is translated to an IPv6 packet. Alright, now this NAT 64 router, it is going to translate the different IP addresses between the networks. Okay, this router is going to translate different IP addresses between the networks so that the PCs with different IP addresses can communicate with each other. Okay, so it is similar to NAT only, there is no complication with that. So this is also one of the techniques that is there in NAT. I hope you have understood this thing.